Hello everyone, this is Terry for terrythetutor.com going over my intermediate algebra chapter 3 practice test. You, depending on what book you have, may not have it in chapter 3, but I'm sure a lot of the concepts are the same. What we're going to be doing is going over each question step by step, and I've already begun number 1. I thought I was recording and I wasn't. So I'll just I erased the answers already. But what the question reads, if you want a copy of the test, you can go to my website, terrythetutor.com, and find the video, Chapter 3 Practice Test Intermediate Algebra, and there's a link to the PDF, because I will not be writing every single question down. I have a piece of paper in front of me. I printed it out. Alright, so let's jump into number 1. The question reads, what quadrant is the point located in? Well, depending on what we know about quadrants, we can determine what point, where the point is located, what quadrant. For example, in quadrant 1, this quadrant, we know that both the x and the y values are positive. And in quadrant 2, the x value is negative and the y value is positive. Quadrant 3, they're both negative, as you can see. And in quadrant 4, the x is positive and the y is negative. With this information, we can determine what quadrant each point is in. So, 2 and 7, those are both positive numbers. Therefore, it lies in quadrant 1. Quadrant letter B, we've got 3, negative 1. Well, that's a positive x and a negative y. That's quadrant 4. I'm sure you can see how easy this type of question is. Both negatives, well, that's quadrant 3. We've got negative 4, 1. That is quadrant 2, it looks like. So we're going to just go ahead and say quadrant 2. And then a trick question, 0, 0. Well, that's actually the origin. It's not in any quadrant. So what you can just go ahead and do is label it the origin. Alright, let's go into number 2, where the test gets a little bit more challenging. What we're asked to do is find the x and y intercepts of the equation. And before you can do this, you really have to understand what an intercept is. So let's go ahead and draw this little graph, and let's draw a line. Okay. An intercept is wherever the graph or line, whatever you want to call it, crosses the axis. For example, this is the y-axis, and so where the graph crosses the y-axis, that's called right here, this is the y-intercept. And what I want you to notice about the y-intercept is that the x value is 0. So, and that can be said for every y-intercept. The x value of every y-intercept is 0. Now let's take a look at the x-intercept, where it crosses the x-axis. This is the x-axis. The graph crosses the x-axis right there. And what is the y value? Well, the y value equals 0 at every single x-intercept. So we can use that piece of information to our advantage. For example, we've got letter A, we've got 3y minus 7x equals 11. To solve for the x-intercept, I set y equal to 0. So I've got 3 times 0 minus 7x equals 11. Well, 3 times 0 is 0. And I've now got negative 7x equals 11. And then I can divide both sides by 7, and I get x equals 11 over negative 7. Alright. Unfortunately, this is a vertical line. Vertical line. And an intercept, if you look, is just a point. So if we were to graph negative 11 over 7, we might get something a little bit like this. And that's not an intercept, that's a line. Actually, it should be a solid line. Okay. But what the intercept is referring to is where it crosses the x-axis, right there. And so what we can do is we can just turn this into a point, because that's what an intercept is, by saying, well, what's my x value? That is negative 11 over 7. And what's the y value at every x-intercept? 0. And that's an acceptable answer. Let's go ahead and try well, no. I almost jumped the gun. We've only found the x-intercept. Now let's find the y-intercept. Finding the y-intercept, we set x equal to 0. So we can say 3y minus 7 times 0 equals 11. And 7 times 0 is 0, so we get 3y equals 11. And solving for y, we divide both sides by 3. We get y equals 11 over 3. This right here is a horizontal line, though. Something like that would look like this. That's a horizontal line. And that's not an intercept. The intercept is where it crosses the axis right there. So what we can do is we can say what the x value is of every y-intercept. Well, that's 0, so we can say 0. And whatever our value is, 11 over 3. And that's an acceptable answer. So you can see how this is going. Now that you understand what an intercept is, we'll proceed a little bit a little bit quicker. Let's go ahead and do B. We've got x minus y equals 0. Solving for the x-intercept, I'm going to set y equal to 0. So I've got x minus 0 equals 0, or x equals 0. If I were to add 0 to both sides, then 0 plus 0 is still 0. So I've got x equals 0. But again, that's a line, so let's go ahead and give the point of the y-intercept. I mean, of the y value, because so we've got the x value is 0, and the y value every time is 0. Now let's go ahead and use let's find the y-intercept by setting x equal to 0. So we get negative y, 0 minus y equals 0. Or negative y equals 0. Or we can divide both sides by negative 1. And we'll get, what is 0 divided by negative 1? Well, that's 0. So we've got y equals 0. And so what's the point? Well, the point of any y-intercept, the x value is 0. And this is our y value, so that's 0. So our our y-intercept and our x-intercept. Part C. Y equals 3. Well, this one, if we know what a vertical line looks like, a horizontal line, then we can answer this question. Y equals 3. 1, 2, 3. That's the horizontal line. Can you tell me where that graph crosses the x-axis? It's a trick question, it doesn't. So there is no x-intercept, there's only a y-intercept. And where's that y-intercept? Well, of course, it's at the y value of 3. But what's the x value? For every y-intercept, 0. So 0, 3. Let's go ahead and do part D. X equals negative 5. The same sort of trick. 1, 2, 3, 4, 5. We've got our vertical line. Where does this cross the y-axis? Well, it doesn't. And so the x-intercept is negative 5, 0, because that's the y value at the x-intercept, since there is no y-intercept. Alright, letter E. we've got y plus 5 minus x equals 0. Well, alright. How do I do this one? Well, the same way I've been doing them. Let's go ahead and set y equal to 0 to solve for my x-intercept. So I've got 0 plus 5 equals negative x. Whoops. 0 plus 5 minus x equals 0. So I add x to both sides, but I get 5 equals x. Of course, that's a line, so the x-intercept is 5, 0. Now let's go ahead and find the y-intercept. We've got y plus 5 minus 0 equals 0, or y plus 5 equals 0. Subtracting 5 from both sides, we get y equals negative 5. Or, the correct answer is 0, negative 5. Good. Part E, did we already do? Now let's do F. Again, if you haven't attempted this on your own, then watching the solution video will not help you too much. So please attempt to do these on your own. So we've got 6x plus 5y equals negative 13. Whoops, let's make that big again. Okay, so solving for the x-intercept, I've got 6x plus 5 times 0 equals negative 13, or 6x equals negative 13, or x equals negative 13 over 6, which is negative 13 over 6, 0. Now let's do the y-intercept, which is 6 times 0 plus 5y equals negative 13, or 5y equals negative 13, or y equals negative 13 over 5, which puts us at 0, negative 13 over 5. Good. Okay, that finishes number 2. Let's go ahead and jump into number 3. Where the directions read, find the midpoint of the line segment with the given endpoints. Okay. Before we can begin, we have to know what the midpoint formula is. I'll let you take a second to think about it. Alright. The midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And that's just how you find the midpoint if you're given 2 endpoints. So let's start with number 1. Letter A, excuse me. We've got the points, the endpoints, 1, 1, and negative 1, 1. Well, let's go ahead and label these. We've got x1, y1, x2, y2, and then we go ahead and plug it straight into the formula. We've got 1 plus negative 1 over 2, comma, 1 plus 1 over 2. Okay. Well, what is 1 plus negative 1? 0. So we've got 0 over 2, comma, 1 plus 1 is 2, 2 over 2. Or, 0 divided by 2 is 0, 2 divided by 2 is 1. 0, comma 1. Midpoint. Let's go ahead and try letter B. We've got 4, negative 3, and negative 2, 2. Okay, let's write, well, I'm sure everyone knows the midpoint formula, so we can just go ahead and plug it right in. So we've got, let's open it up, we've got negative 2 plus 4 over 2, comma, 2 plus negative 3, 2, comma, well, close parenthesis. Negative 2 plus 4 is positive 2, divided by 2 is 1. 2 plus negative 3 is negative 1, divided by 2 is negative 1/2. That's the midpoint. Part C. We've got 1/2, 1/3, and negative 1/2, negative 2/3. Interesting. Well, let's plug it right into our formula. We've got negative 1/2 plus 1/2 over 2, comma, negative 2/3 plus 1/3 divided by 2. Well, we've got negative 1/2 plus 1/2. Well, that's 0. 0 divided by 2 is 0. Now we've got 2/3. Whenever you add fractions, as long as they have the same denominator, you can just add straight across. So I've got negative 2 plus 1. That'll give me negative 1, and we keep the denominator the same, negative 1/3. So we've got 0, negative 1/3 divided by 2. Okay, there's two ways to see this, and we'll go over both of them. What we can say is we've got negative 1/3 divided by 2, which works, and I'll show you the second way after. It's better if you see this. What we have is an acronym called KFC. Kentucky Fried Chicken. No, I'm just kidding. It's keep, flip, change. I guess it's KCF. So this is 2 over 1, which is what makes 2. So we're going to keep this. We got negative 1/3. We're going to change this to multiplication, and then we're going to flip this to make it 2. No, it's going to make it 1 over 2. And then to multiply fractions, you just go straight across. So that gives me negative 1 over 6. Okay, so our answer is negative 1 over 6 for the y value. I guess I shouldn't box that. Okay, so that's one way to do it. That's one way to solve this thing. Another way is to look at this. Let's go ahead and give it a different color. Blue over 1. Okay. So what you can do is you can quickly multiply 3 over 2. Well, 3 times 2. And then you can multiply negative 1 and 1. And if you do that, you'll get negative 1 and 1. Well, that's negative 1. Done. 3 over 2. 3 times 2. Well, that's 6. Voila. Whichever one works best for you. If you're still learning, I'd probably advise the KFC method. So our midpoint would wind up being 0, comma, negative 1 over 6. Let's go ahead and start part D. That one looks challenging. We've got 5 over 3, 7 over 3, and 10 over 6, 14 over 6. Interesting. Well, let's just go ahead and plug it right into the formula. I've got 10 over 6 plus 5 over 3 over 2, comma, 14 over 6 plus 7 over 3 over 2. For those of you who made it this far, if you are wondering why I'm setting this is my x1, y1, x2, y2, some of you may be asking, why is he putting 10 over 6 in the x1 place? Well, because it's addition, I can add in any order. For example, if I had 4 plus 6, I'd get 10. If I had 6 plus 4, I'd get 10. So anytime you have addition, it doesn't really matter the order. Alright? Alright. Let's continue. Well, let me erase this red mark. Oops, didn't mean to get rid of that. Okay, so before I can add these fractions, they have to have a common denominator. There's two ways to do that. I can either reduce, or I can bring this one higher. Let's go ahead and do the standard by just bringing the lower one to the higher one. So 3 goes into 6 twice. So I'm going to multiply both the top and the bottom by 2. What this does is this will multiply 3 times 2, giving me 6, and hence a common denominator so I can add. Of course, I also have to do the same to the numerator. Now let's go ahead and do that here to 7. 3 and 6, again, same scenario. So let's multiply by 2 and by 2. So now what I've got is 10 over 6. What is 5 times 2? Well, that's 10. So we got plus 10 over 6 divided by 2. And then we've got 14 plus, 14 over 6 plus 7 times 2 is 14 over 3 times 2 is 6 all over 2. Alright. Now that I've got common denominators, I can just add straight across and keep the denominator. So 10 plus 10 is 20 over 6 over 2, comma, 28 over 6 over 2. Now remember that trick I taught you up there? Last question? Well, we're going to go ahead and use it. Let's multiply 6 and 2 and 6 and 2. What does that give us? Well, that gives us 12. So I've got 20 over 12 and 28 over 12. Now the only thing left to do is to reduce. A 2 goes into both of these. A 2 goes into both 20 and 12. So I'll go ahead and pull out a 2. I factor 20 and I'm left with 10. And I factor 12. A 2 out of 12 and I'm left with 6. And then I go ahead and I factor 28. I'll pull out a 2 and I've got 14. And I pull out a 2 of 12 and I got 6. So these 2's cancel. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times anything is itself. So now I'm going to, I can pull out another 2 again. So I've got 2 times 5 over 2 times 3. And 2 times 7 over 2 times 3. And these 2's cancel again. And my final answer will be 5 over 3, comma, 7 over 3. That's our final midpoint. That one was a lot of work, but that's okay. Let's jump right into number 4. 4. Our instructions read, decide whether each pair of lines are parallel, perpendicular, or neither. Okay, so for part A, we've got a line passing through, and here's the ordered pairs, 3 comma 6 and 7 comma 8, and another line, line 1, here's line 2. We've got negative 6 comma 4 and 8 comma 5. Alright. When it comes to parallel, perpendicular, or neither lines, the only important thing is slope. So what we're going to do is we're going to observe we're going to try and find the first line's slope. First thing we need is the formula for slope, which is y2 minus y1 over x2 minus x1. That's slope. So I'm going to say x1, y1, x2, y2. And I'm going to see that I've got, for this one, I've got 8 minus 6 over 7 minus 3 is 7 minus 3. Okay. So that's 2 over 4. 7 minus 3, is that 4? It is. And then I've got 1 half. Okay, well that's my slope. That's my m. For line 1. And also do the same thing for line 2. I've got 5 minus 4 over 8 minus negative 6. Well, that's 1 over 8 minus 6 makes it a positive. A minus and a minus is a positive. 1 over 14. That's m2. So are these slopes the same? I guess I should say, if they're parallel lines, same slope. Perpendicular lines, they have negative reciprocals, slopes, like this. Let's say we had b over a. Well, a perpendicular line would have negative a over b. Okay? And neither is if there's no correlation. So let's look. Well, they're not the same. They're both positive, so they can't be perpendicular. So the answer is neither. Let's go ahead and try letter B. We've got y equals 4x plus 12 and 36 plus 4y equals negative x. Okay. Well, what form of a line can I determine the slope in? Well, slope intercept, which looks like this: y equals mx plus b, if you didn't know. So my goal is going to be to get both of these lines into slope-intercept form and then identify their slope. For example, this line is already in slope-intercept form, and my slope, m is my slope, so here's my m, with the 1 next to x, so my slope is 4. Now let's see if we can find the slope of this line. Let's do it in blue. I like blue. So first I have to solve for y to get it into slope-intercept form. So I've got 4y equals negative x, and then we've got minus 36. Okay. Now let's go ahead and divide both sides by 4. So I get y equals negative 1/4 x minus 36 divided by 4 is 9. Okay, so here's my slope-intercept form. Here is my slope. So this m is negative 1/4. So, are they the same? No. I'm busy. Whoops. That's embarrassing. I meant to hit decline. Anyway, what we're doing is we're going to determine if they're parallel, perpendicular, or neither. And these are not parallel, they're not the same, but their slopes are negative, meaning opposite. One is positive, one is negative, and they're reciprocals. So they happen to be, what is a reciprocal? A reciprocal is, let's say I did 2 over 1. Well, the reciprocal of that is 1 over 2. So these are perpendicular. Okay, let's move into part C. We've got 1/2, 1/3, and -1/2, -2/3. Okay, let's go ahead and I'm looking at the wrong thing. I guess that Skype call messed me up. That's number 3. Let's look at number 4. Letter C for that is a little bit different. 2x plus 5y equals 8, and 6 plus 3x equals 5y. Okay, to determine if they're parallel, perpendicular, or neither, what we are going to do is we are going to first identify the slope, the same thing we did before. So we are going to have to get it into slope-intercept form. I think that's only natural. So let's start with the first one. Let's first subtract 2x from both sides. I've got 5y equals -2x plus 8. Then I'm going to divide both sides by 5. So I've got y equals -2 over 5 x plus 8 over 5. Okay, here's line 1. What is the slope of this one? Well, the slope is -2 over 5. Let's find the slope for this guy. So I'm going to, well, this one's already got y on the other side. So I'm going to just divide both sides by 5. So I've got y equals 3 over 5x plus 6 over 5. So my slope is 3 over 5. Are they the same? No. Are they opposite? Yes, they're opposite signs. Are they reciprocals? No. So, they're neither. It's all or nothing. Beautiful. Let's move on to number 5. Where the number 5's instructions read, graph each line described. Okay, so we've got number 5. We're asked to graph. So we've got letter A. Graph through 0, 0 with a slope of 1. Alright. Well, let's go ahead. Let's pull up some graphing tools. Graphing. This will be fun. Whoops, where'd it go? There we go. Okay, so let's draw some tick marks. Okay, I'll copy paste that for the next ones. Let's make that one thicker. Okay, so I know it goes through 0, 0, so that's a point. And the slope is 1. And if you're trying to figure out rise over run, well, that's just 1 over 1. So I rise 1, I go to the right one. I rise 1, I go to the right one. And I can see what my line is going to look like. My line looks like that. Okay. That's an easy graph. Let's try part B. Through -2, 1 with a slope of 5 over 4. That's a pretty big slope. I guess I have to redraw it, but that's okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it goes through negative 2, 1, which is exactly there. And the slope is 5 over 4. And that translates into rise over run. So we go up 5. 1, 2, 3, 4, 5. And we run 4. So we're up 5, and then we go 1, 2, 3, 4. There's our second dot. Now let's connect them. Let's try this arrow, see what that does. Now that works pretty well. Not the best, but that's okay. Okay, that's our graph. It should come down a little bit as well. Not as straight as the computer, but whatever. You get the idea. The graph is complete. Good. Now let's try part C. C. We've got a line passing through negative 2, negative 4, with a slope of 2. Let's go ahead and make our graph again. This is kind of fun making that graph. So I've got 1, 2, 3, 4, 1, 2, 1, 2, 1, 2. Well, my initial point is way down, negative 2, so that's to the left 2, and down 4, which is right... Oh no, I meant to color you in. Right there. And the slope is 2 over 1. Not 2, what am I doing? Erase. That works. 2 over 1, which is, of course, rise over run, like we're familiar with. So we're going to rise 2, 1, 2, and then we're going to go over 1, 1. And we're going to rise 2, 1, 2, and we're going to go over 1. If I would have drawn it a little bit more proportional, it would have looked better, but there's our line. Let's erase that second dot. It sucked. There we go. We can graph. Not surprisingly. Okay, let's go into number 6. Where the directions read, write the equation of a line that satisfies the given conditions in standard form and slope-intercept form. Viewer who is not able to talk to me, remind me to put it in both forms, because I will forget. Okay. Now that you know your job is to remind me, I know you will. Let's do part A. So the conditions are that it passes through the points 2, 3, and 6, 9. Okay. Well, if I'm going to graph this... No, I have to write the equation. It's not even graph. To write the equation, I think I need to find... Well, what's a formula that will let me write an equation for a line? I only know of one. It's called the slope... No, point slope form. Point slope form. So this is a key for these kinds of questions. Write the equation of a line that satisfies the given conditions. And the equation for that is y minus y1 equals m times x minus x1. Okay, so we've got y. I guess we should find the slope first, huh? Because we don't have a slope. We've got 2 points to pick from, which we could choose either one. But we do not have a slope. So let's find the slope. Thankfully, we have a slope formula, x1, y1, x2, y2. The slope is y2 minus y1 over x2 minus x1. So we've got 9 minus 3 over 6 minus 2, and that is I minus 3 is 6 over 4. I can factor out a 2 from both of them, so the 2's will cancel, and I'm left with 3 over 2. So that is my slope. Awesome. Well, with that slope, we can now use this formula, because we need a point, a single point. So we're not going to use both of them. We're going to choose one. And a slope. Let me write this formula down here. Y minus y1 equals m times x minus x1. Okay. What we need to understand is what is being plugged in for here. Well, y1 is going to be plugged in for. That's going to be our y value of the point we choose. x1 is being plugged in for. That's the x value of the point we choose. And m is being plugged in for. Everything else is going to stay, because those are going to be the x and y values. Those are going to be the x's and the y's that remain in our equation. Remember, that's what we're doing. We're writing the equation of a line. So these need to stay, so they will. So let's go ahead and choose 2, 3. The point we're using is 2, 3. So I've got y minus, here's my y value, 3, equals, what did I write that parenthesis for? Equals 3 over 2 times x minus 2. Alright. Using my distributive property, I distribute the 3 over 2 into both, so I've got y minus 3 equals 3 over 2x minus 3 over 2 times 2. Well, if we've got 3 over 2 times 2, these 2's will cancel, and we've just got y minus 3 equals 3 over 2x minus 3. Now let's add 3 to both sides, and I get y equals 3 over 2x. Is that correct? Well, it looks as if it is correct. Great. So what we found is this is actually the slope intercept form that the question was asking for, because actually what the b is plus 0. So this is y equals mx plus b. B is 0. And now let's find the standard form, which is a lot less work than all of this getting up to it. There's only 3 rules we have to know for standard form. Standard form rules. Form rules. No fractions, ever. X cannot be negative. X can't have a negative coefficient. Meaning it can't have a negative number in front of it. And 3, they cannot all have a number that divides into them. No common factors, no common factors between all 3. Some of you might be saying, well, gee, Terry, I see x and I see y, but what is the third? Well, that's probably because you haven't seen standard form just yet. Let me explain. We've got ax plus by equals c. So in this case, we're talking about a, b, and c, meaning all 3. B is the coefficient of y, a is the coefficient of x, and c is the constant on the other end. So to get into this form, from this form, let's write that formula. Y equals positive 3 over 2x. To get it into this form, we need to put the x on that side of the equal sign. So let's subtract 3 over 2x from both sides. So I've got negative 3 over 2x plus y equals 0. Okay. C can be 0, that's fair. That's fine. C can be 0. Fine. But x, well, we know that there can be no... x can't be negative, first of all. So this is an issue. And there can be no fractions, so that's an issue. So let's get rid of them both with one step. Let's go ahead and multiply everything, both sides, by negative 2. What that'll do is it'll cancel out the negative, and it'll cancel out that 2 in the denominator. Okay, so I've got those 2's cancel, and I got 3y. No, 3y, what am I saying? 3x, this 2 distributes there and there, minus 2y equals negative 2 times 0 is 0. And that's our standard form. That one was pretty long. Let's go ahead and do part B. That one's a little easier. There's a trick to it. They want us to write the equation of a line that satisfies the given conditions. So we're going through 3, 1, and it has an undefined slope. Alright, let's see how long we've been recording. Not too long. Only 40 minutes. Let's minimize you again. Undefined slope. Well, what we have to do is think. I know, that's so hard. Just kidding. What do we know about undefined slope? How does that relate to us? Well, earlier on we learned about vertical lines. And we learned that vertical lines had undefined slope. So we know that this is a vertical line. Now, what does the equation of a vertical line look like? Well, it's usually x equals some number. Usually, it's the same. Usually, it's the x value. So, if we know it goes through 3, 1, well, let's imagine this is 1, 2, 3, and then 3, 1 is right there. If it goes through right there, what is our x equal to? Well, the answer is x equals 3. That is actually both slope intercept and standard form. Both. So remember that. Whenever you've got one variable eliminated, namely the y, then you can just go ahead and do that for both. Alright. That was easy. Quick and painless. And conceptual. Let's go ahead and do C. Through negative 1, 4, parallel to y minus 14 equals negative x. Well, what is parallel telling me? Parallel is telling me that they have the same slope. So I need to find out what the slope of this line is. How do I do that? I need to find out what the slope of this line is so I can find out the slope of my own line that I need to make. I can do that by getting into slope intercept form. So I'm going to solve for y. I get y equals, I add 14 to both sides, and I get negative x plus 14. My slope, m, equals negative 1 over 1, or negative 1. Because there's an imaginary negative 1 in front of the x. Yes. Both of those answers are acceptable. Now, let's go ahead and use that y minus y1 strategy. That nice little formula. And plug it into this. And we'll be done. So we've got y minus 4 equals negative 1 times x minus 1. Well, the first of all, minus 1, y minus 4 equals negative 1, x, that's going to be a plus, so plus 1. Now let's go ahead and distribute this negative 1 into both of those, and so we'll wind up with y minus 4 equals negative x minus 1. Now let's go ahead and add 4 to both sides. Plus 4, so I've got y equals negative x plus 3. Well, that's slope-intercept form. Slope-intercept. What's standard? Let's add x to both sides. So I add x. So I've got x plus y equals 3. And that's standard form. So we got both of them really fast. Standard. Once you know the standard form rules, it's cake. Alright, we're coming up close to the end of number 6. D goes through 4, 5 and perpendicular to x plus y equals 4. What do we know about perpendicular lines? We know that their slopes are opposite reciprocals. So, first I need to find this line's slope so I can find the slope of the line I'm going to make. I can do that by putting it into y equals mx plus b form. So I subtract x from both sides, and I get y equals negative x plus 4. So this slope is negative 1. So the slope that I want to focus on is actually going to be positive 1. Well, this is negative 1 over 1. So the negative reciprocal, well, the opposite reciprocal would be positive 1 over 1. So that is, the slope I want is positive 1. Or positive 1 over 1. Same idea. That's my slope. So let's go ahead and do that same process. Y minus y1 equals m times x minus x1. And I've got to plug in my y value and my x value. So I've got y minus 5 equals, what's my m? My m is 1. 1 times x minus 4. Alright, so I distribute this 1, which effectively does nothing, but I've got y minus 5 equals x minus 4. Now let's add 5 to both sides, and I've got y equals x plus 1. And that is slope-intercept form. Slope-intercept. Now how do I get into standard? Well, let's subtract x from both sides, and I get negative x plus y equals 1. Remember, I can't have a negative x, so I'm going to multiply everything by negative 1. So this negative 1 distributes, and I've got x minus y equals 1 times negative 1, negative 1. Beautiful. That's standard. Okay. We're almost done. We just need to do 7, 8, and 9, and we'll be finished. Why don't we go ahead and get started with number 7? I appreciate those of you who've stuck with me thus far, if anyone has. If not, I completely understand. This stuff is pretty dry, but that's okay. The directions read: graph the intersection of each pair of inequalities. So, letter A, I've got y plus x is less than or equal to 1, and x is greater than or equal to 2. So we've got to graph the intersection of each pair of inequalities. Well, looks like we're asked to graph again, so let's go ahead and bust out the graphing tool. Oops, where'd it go? Awesome. So, the first thing that we need to do in graphing, let's go ahead and make our tick marks, of course, who wouldn't? Then, we've got to try and get everything into forms that we can graph with. We can graph with only one, slope-intercept form, which is y equals mx plus b, where we know the slope and the y-intercept. So I'm going to try and put this into slope-intercept form by subtracting x from both sides. So I've got y is less than or equal to negative x plus 1. Okay, I can graph that. And I know what the line x is greater than or equal to 2 looks like. Does anyone remember what a vertical line will look like? Well, it looks like that. That's the line x equals 2. So, the only difference is we have to decide to shade, so we'll handle that last. Alright, so I've graphed this one. We're doing shading last again. Now let's graph this guy, this one. So I'm going to say the y-intercept is 1, and the slope is negative 1 over 1. So I go over 1, go down 1, go over 1, go down 1. Looks like the intersection. So let's go ahead and connect them. Connect. That's not the best lines. I'm not the best artist. But you get the idea. Now what we have to do is shade. We have to shade, excuse me, we have to shade where x values are greater than 2. X values are greater than 2. Where are those greater than 2 at? Well, they're all greater than 2 everywhere on this side of that line. Everywhere. Okay, so let's erase that, because that's not our answer. And we also have to shade where the y values are less than, meaning below this line, below this line. So if it's to the right of this line and below this line, it's got to be right in this little crevice. It's to the right and below. And everything below is going to be our answer. Awesome. Let's go ahead and go into 7b. Oh, whoops, I did it again. 7, well, let's just put b. B. We've got y is greater than or equal to 4 over 3 plus 3, and y is less than negative 2. So let's go ahead and draw our graph. Oh, I think that's what destroys it. Me moving. Got black still, okay. 1, 2, 3, 4, 1, 2, 3, 4. 2, 3, 4, 1, 2, 3, 4. Alright. First thing I'm going to do is the same thing I did last time. Let's graph this one first, the easy one. So this is y is equal to negative 2, which is a horizontal line. Not equal to, it's less than. If it's less than and not equal to, it's a dotted line. So it's a dotted line. Silly me. Dotted line. And if it does have an equal to, let's do red, then it is going to have a solid line. Okay, this one is already in slope-intercept form, thankfully. So let's go ahead and use the y-intercept, which is positive 3. Positive 3 is way up here. What am I doing? And the rise over run is I can go up 4. No, this is a good time to explain. Okay. The difference between, well, actually more like the correlation between 4 over 3 versus negative 4 over negative 3. If you're observant, you'll see that negative 4 over negative 3 is the same as 4 over 3, because I can simply cancel. But if you're relating this to rise over run, it's a good technique to have, because we just established that they're exactly the same. They're the same. But sometimes I don't have enough room on my graph to go up 4 units and to the right 3. I didn't make it because I didn't have enough foresight. But so what I can do is I can go down 4 and to the left 3. So let's do that. 1, 2, 3, 4. To the left 3, 1, 2, 3. Here's my second point. There's their intersection. And now we have to decide where to shade. Well, it needs to be greater than this line, so it needs to be above. And it needs to be less than this line, so it needs to be below. So it's going to be right in this little corner. If these were to extend, it would be right there. It needs to meet both conditions, but cannot only meet one. So it meets both and not only one. All right. Let's go into part C. We've got 3x minus 2y is less than 5, and x is greater than 5. It looks like 25. It's not 25. It's less than. Okay, so first thing to do is, actually let's put this into slope-intercept form first. Let's subtract 3x from both sides, so I get negative 2y less than negative 3x plus 5. Let's divide by negative 2. Here's where everything gets a little bit complicated with these. Whenever you divide or multiply by a negative number, divide, multiply by a negative, you flip the inequality. Okay, so let's see. If I divide by negative 2, that means that I'll have, these will cancel, and I'll have y negative, actually that should be positive 3 over 2. 3 over 2x minus 5 over 2. Now, what about the inequality? Well, it's flipped, so it's this way now. Okay, as long as we all understand. Let's scroll down first, because that keeps happening. Alright. Let's use a bigger one. Erase. Why not? So, we've got to say, oh, put my eraser away. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Awesome. First thing I'm going to do is graph the easy one, that one. Greater than 5, well that's this line right here. And it's dotted because it does not have an equal to sign. Well, I guess I could have done that better. There it is. And of course the arrowheads, it goes on forever. Now let's graph this one. It is y-intercept of negative 5 over 2, which is about 2.5. It's exactly 2.5. So 1, 2.5. And now let's rise 3. 1, 2, 3, and go over 2. 1, 2. Now these, we can make that line. Oh, kind of. Okay, that'll work. There's our line. Okay. Arrowheads, of course. They do matter. So we've got to decide on the shading now. Oh my gosh, this is supposed to be dotted. Let's see if we can change the eraser. Medium eraser. It's a dotted line now. It's a dotted line. Beautiful. Beautiful dotted line. With that said, now we've got to decide where to shade, like I said. So we need to shade above this blue line, which is going to be up here, and we need to shade above, we need to shade where the x values are greater than 5, which is to the right. So it's going to be everywhere in this corner. Actually, it gets very big very fast, but you get the idea. That's where the shading is. Alright, let's go on to number 8. The directions read, decide whether each relation is a function. Give the domain and range. Alright, so for letter A, we've got a graph that says x, y, 3, -1, 5, 6, 3. And 16, 11, 5, 3, -2. So the first thing we have to do is determine whether or not they're a function. You can do that by remembering that what makes a relation a function is if there's no repeating x values. I think I see some repeating x values right here and here. So, not a function. Easy enough. Now let's see, what is the domain and range? The domain are all the x values, and the range are all the y values. You just got to use set notation. So I've got my x value is 3, -1, 5, 6, and that's it. Remember, set notation does not have any redundancy, so you don't write the same number twice. You don't even have to write them in order. What's the range? 16, 11, 5, 3, -2. There it is. These are everything we need. Let's look at part B. We've got 2 little bubbles, and it says 2, 1, 5. And then we've got another bubble that says 6, 11, 3. And they connect in this manner. I guess that should connect, huh? Okay. So we assume that the first bubble is x values and the second bubble is y values. I see that this 2 does not correspond to more than one y value. So it is a function. Yes. If this 2 were to sprout off to both, then it would not be. Okay. So what's the domain? The domain is 2, 1, well, I guess I should write it side by side. 1, 5. That was easy. And what's the range? 6, 11, 3. Alright. Part C. This one's a graph. We've got a circle, 1, 2, 1, 2, 1, 2, 1, 2. Got a circle. I guess that's a horrible circle. Okay. And we've got to decide domain and range. Well, the domain is everywhere that the graph exists. From where to where does the graph exist? On the x-axis. Well, the graph begins existing right there. And it goes up, but again, we're only relating x values. And then it comes down, and then it stops existing right there. That's supposed to be the x value 2. So the domain, if it begins existing and includes -2, then we can, this bracket equals includes. Parenthesis, not include. Okay, So the domain is from -2 to 2. It does include, so why am I putting parentheses? That's silly. Okay. And range. Well, it begins existing on the y-axis right there, and it comes up and it does its thing, and then it stops existing right there. It's supposed to be 2. So it begins at -2 and ends at 2. Some of you may have seen something like this, where it's like -infinity to infinity, and they put parentheses. The reason why they put parentheses on infinities is because you cannot actually reach infinity. It doesn't include it, because infinity is not a real number. It's simply a concept. Okay. Now our last question, with 6 parts, not too bad. Number 9. We're told that f of x equals 2x minus 4, and g of x equals -2x squared plus 3x. And then we're just thrown right in. They say, find the f of 0. F of 0. What does that equal? Well, because each function is named function f, I'm not going to use function g. That wouldn't make any sense, right? So I'm going to use this function, and because there's an x here, and then all of a sudden the x got replaced with 0, everywhere I see an x, I'm going to replace it with 0. You're right. Whoever is listening and talking out loud. 2 times 0 minus 4. So what is 2 times 0? Well, that's 0. So the answer is the f of 0 equals -4. It's that easy. We're going to power through these ones. B. The g of -1. Well, I'm going to replace my -1 with all these x's. So I've got -2 times -1 squared plus 3 times -1. Well, we have to do it step by step, order of operations. -1 squared first. -1 times -1 is equal to +1. So I've got -2 times 1 plus 3 times -1. 3 times -1. Alright. So we've got -2 minus 3, or 5. So the g of -1 equals 5. It's important you leave your answer in that notation, because it shows you understand what function notation is doing. C. The f of -x. Well, I've got 2x minus 4, so I'm going to replace this x with -x. So I've got 2 times -x minus 4. What is 2 times -x? Well, that's -2x, so I've got -2x minus 4. And that's it. D. What does that say? F of 11 over 5. That's interesting. Well, I'm going to replace my x with 11 over 5. So I've got 2 times 11 over 5 minus 4. 2 times 11 is 22. So I've got 22 over 5 minus 4. Now I can get a common denominator because this is 4 over 1. So I'm going to go ahead and multiply both the top and the bottom by 5 to get a common denominator of 5. So I've got 22 over 5 minus 4 times 5 is 20. 20 over 5. And that's equal to 2 over 5. So the answer is f of 11 over 5 equals 2 over 5. E. F of -2 over x. Interesting. Well, that's equal to, we've got 2 times -2 over x minus 4. I can just, this is 2 over 1, so I multiply straight across, and I get negative 4 over x minus 4. And that's our answer. Because we can't reduce that anymore. And f. The f of 2x plus 1. This is where most people get confused. This is the hardest one, as far as function notation goes. So what we've got is 2 times 2x plus 1. We replaced everything that was an x before, and we just put it in some parentheses, minus 4. Using our distributive property, we distribute, and we get 4x. 2 times 1 is 2, minus 4. So we've got 4x, then minus 2, the f of 2x plus 1. Awesome. All right, everybody. Thank you to everyone who stuck around till the end. If you have any questions, remember you can go to terrythetutor.com/ask and have your question featured in a video like this. Of course, your video will probably not take, how long have we been recording? Will probably not take an hour and 16 minutes. I hope I've been able to help some of you. And if you're watching and you're from my class, then good luck on your test tomorrow. I've been Terry the Tutor, and I'll talk to you later.